So this video is to go over investigation 4B. So in investigation 4B, we explored dilation, and that means you applied the scale factors to construct enlargements and reductions. And you also explored choices for the center of dilation, and also you'll learn the ratio and parallel method. And so for example, let's go over the ratio method first. So let's say these are the method that dilates a figure. Either dilate means either makes figure bigger or smaller without changing the shape. So let's say we have triangle ABC. Take the center of dilation, let's call it L. This time it's outside. And then draw a ray from the center of center of dilation to point B. And let's say we want to dilate it by factor half. So you're gonna make the segment LB into half and place B prime. And then you do the same thing for all points. So draw LA, split it into half, take the midpoint in other words, and call it A prime. And also draw ray to C and draw a midpoint, and let's call that C prime. And if you connect that, you get dilated or scaled figure of triangle ABC. We call it A prime, B prime, C prime. How does this work? So if you just concentrate the triangle L, B, A, and A prime, B prime. So if we take that part, we'll have L, B, A. And then we have A prime and B prime. And as you see, that's actually the triangle with midlines A prime, B prime. And the midline, we can apply the midline theorem, says that if the midlines A prime, B prime is a half of AB, so A prime, B prime is half of AB, and also A prime, B prime, segment A prime, B prime is actually parallel to, just erase that, parallel to AB. And that tells us that, that shows us that A prime, B prime is parallel to AB. And if you look at other triangles, for example, LCA and A prime, C prime instead, then we can apply the same thing. So what if we have center of dilation inside the figure? So let's take ABC, triangle ABC. Let's take L in the middle, and let's do the same thing. From the center of dilation, you draw ray to each vertex, and then take half and connect it. Then that's going to be the scaled version of original ABC. And that's going to lead us, that's the ratio method, and we can also have those center of dilation on the vertex or on segments, and then you take the segment, you take the half of LB. Well, LA is the distance of LA is 0, so if you take it half, it's 0, so it stays at the same place. Take LB and take half of it. Let's call B prime. So, and then do the same thing for C. Then we get the scaled version of ABC. So how do we do parallel method? So let's take trapezoid ABC, D, and let's plot the points, center of dilation L. And you pretty much do the same thing. You draw a ray to L. Let's use the scale factor of 2. And draw a ray to all the vertices. Now, since we are using scale factor of 2, you double the length of LA and plot the points A prime. So LA prime is twice as long as LA. And once you get the A prime, you draw a parallel line to AB passing through A prime, so like that. Let's see if I can do it. And then the intersection point right there, we say B, that's B prime. And from that B prime, we will draw a parallel line to BC. Intersection will be C prime. And from that, draw a parallel line to DC. That's D prime. And if you connect A prime and D prime, you get the scaled figure of original one. So here's another thing that makes people confused. So how do we actually use the scale factor of such as 5/3? You know, we know that if you have some triangle like this, and that's going to be a little bigger because 5/3 is bigger than 1. So let me just draw it a little bigger. So if you take triangle ABC, and let's say we take the center of dilation inside the triangle, and let's take the draw a ray to each vertex. So we got LA, LB, LC. And now the units of 5/3 is actually 1/3, right? Because we have 5/3 means we have 5 of 1/3. So now we have to locate 1/3 first. Let's take a look at LA. So if you're talking about LA, we're going to split this into 3 equal pieces. So something like this. And that's 1/3. If you take the 2 of them, then that's going to be 2/3. And if you take 3 of them, 1, 2, and 3, then that's going to be a whole. And 5/3 is actually is whole, which is 3/3, plus 2 of that, 2 more 1/3. So we should take the same length from here to here, 2 more. So you go 1/3, 2/3. So it should be somewhere over here. So you see that? 1/3, 2/3, 3/3, 4/3, and a 5/3. So that's going to be A prime. And from here you can use parallel method or ratio method. You can do the same thing for LB and LC if you want, or you can just simply draw a parallel line to AB, and wherever the intersection will be the B prime. And then from there you draw a parallel line to BC, and the intersection will be C prime, and draw a parallel line, or just simply connect that A prime and C prime, and that's going to be the scaled figure. And this is pretty much what we have learned in investigation 4B. So another question is,